Right, so what we're going to do is we're going to form a box, okay, with a very tidy top and a very tidy bottom. Now by tidy I mean something that you would be comfortable substituting into. So if I told you right now that x was 1, would you be comfortable substituting into that? Would it be quite easy to work out? I think it would be. Square root of 1 is just 1. 1 to the power of 5 is 1. 1 to the power of 3 is 1, so it's 1 plus 1 over 1, so it's 2. Okay? If you were not comfortable doing that, then there must be some better version of that. But I just don't think there is. You can't add this and this because they're not like terms. So that's probably going to be what's in the top row of the multiple choice box. Now, how do we get the bottom row? To get the bottom row, we have to make this ready for calculus. In other words, it has to have the look. Okay? Now the look involves just a string of powers of x with numbers in front of the x's and pluses or minuses in between the terms. Now how do we achieve that from this? Well, the first thing is to do something that is highly counterintuitive because it's the opposite of everything you've ever done. It's to unadd the fraction. In other words, imagine that this came from this. Now what you do is you write this as a power, which we've recently learned roots mean fraction powers, so that's x to the power of half. And now, in this situation where you can physically see 2x as one above the fraction line, one below, you subtract the powers. Half take away 3 is x to the power of negative 2.5. 5 take away 2 is x to the power of 3. That is almost there, but it does not quite obey the look. Yep?
On the bottom of the second fraction.
Oh, I miscopied it, thank you. So that should be a 2. That's not quite the look, it's almost there. Just needs 1s there. Okay? We're now ready to form the bottom row of the multiple choice box. And that is this. dy dx equals. Now we've got to do 4 things from year 2. We've got to do 2 multiplications and 2 subtractions of the number 1. That times that is this. That's the first thing from year 2. Reducing that by 1. This is not quite year 2, maybe year 5. That times that is definitely year 2. And reducing that by 1 is definitely year 2. Now, that's the answer. That's the dy dx. Okay? But there no way is that good enough to go in there because it is horrifically untidy. If I had to work with mixed fractions in a multiplication, I would be much more likely to make a mistake. So when it goes in there, I'm going to change that to an improper fraction. In fact, I'm going to do that right now. And there's no way I would want to have a 1 there if I actually had to work with this. I'm going to leave that 1 off. Now, can I make that a bit tidier? Yes, I can, because fractional powers are an absolute disaster, so are negative powers. So I'm going to try and get rid of them as well. First, I'm going to get rid of the negative power. That came out real simple because negative powers are way easier than people think. When you see a negative power, just pretend it's not there, put your answer under a fraction line. The only difference is that this has gone under the fraction line. Now, almost there. That's tidy, that's reasonably tidy, but what does that actually mean? It means this. Okay, what does a power of 7 over 2 mean? It means square rooting followed by ordinary powering of 7. Now that, I know it's not particularly tidy, but it's way tidier than any of these. So that now goes in the multiple choice box bottom row. And that will have to go in the top row because it's the tidiest version of the rule for y that is currently on the page. And that is it. That is the multiple choice box done. Now, does anyone have any questions about that? There must be some questions. Is everyone cool with this becoming that? Remember, when you have a fractional power, the rooting is determined by the denominator. That's a 2, that's why that's just an ordinary square root sign that you've known for ages. The numerator is just the ordinary powering that occurs after the rooting. So any questions about that? Esther?
If the denominator was higher, would you have to put it in the square root symbol?
If the denominator was higher.
if it was 7 over 3?
If that was a 3, that would now need to be a 3, because the only root that you're allowed to leave out is a square root. Okay? That was a good question. Now, that was supposedly simple, okay? But I think on reflection we'd say just the early part was simple. This was pretty bad. Okay? Well, compared to this one. This is an absolute beast. Okay? Now, this breaks the rules for being ready for calculus, because it's not just terms involving x's separated by pluses and minuses, because there's a hidden multiplication there. There's a very simple fix, which is to multiply out the bracket. I've always recommended that in a situation of great complexity, multiplying out the bracket is actually quite simple, as long as you turn your brain off and literally just write the thing out the front of the bracket twice. So all I'm doing there is writing it twice. Don't write the brackets. Instead, I'll copy across the plus, but write what was in the brackets, write it with what was out the front of the brackets. So that is the expansion of that. I haven't done any maths except write that twice. Write each of them over there with a plus in between and delete the brackets. Now, in order to work with this, I'm going to have to express what that means in an alternative fashion. That is rooting and powering. So the way we write rooting and powering is with a fraction power like this. Remember, the type of rooting goes in the denominator, the type of powering goes in the numerator. And I'm going to do the same thing here. Now, the second term is actually quite straightforward. Just add the powers whenever you can physically see the x twice with a multiplication hidden in between. So that's 2 and 3/5. Now what about this? This is a bit horrible. I'm going to pretend that's over 1 so that I can multiply the fractions with the fractions wrap. Top times top. Bottom times bottom. What we're now going to do is 3/5 take away 3. Oh, there's no way I'll get that right in my head. 3/5 take away 3 is 3/5 take away 3 over 1, which is 3/5 take away 15 over 5, which is negative 12 over 5. Now we're just going to pause there. There must be something that people don't get. So A became B, became C, became D, became E, became F. Somebody must want to ask something about something. Anything? Come on, Amara.
Can you go over all of it? I kind of missed.
Yep, sure. Okay, so A becoming B. Settle down, please. A becoming B is just multiplying out the bracket.
Yeah.
This times this is there, this times this is there, there was a plus in between here, there's a plus in between there. You cool? Now, this becoming this is not much change. The multiplication symbol has been written in. This has been copied down. Now this has become an alternative expression for it. We learnt recently that you don't always have to write the root symbol. You can use a fraction power. Whatever powering is going on is in the numerator. Whatever rooting is going on is in the denominator. Amara, you cool?
Yeah.
I've done that there, and I've also done it there, and that's just been copied down. Amara, you cool? Here I added the powers. 2 plus 3/5 is 2 and 3/5. Here I got ready to do a multiplication with the fraction wrap. The only change is that there's suddenly a 1 underneath.
Okay.
Now you do top times top, written there, bottom times bottom, written there. That's been copied down. I'm going to copy the 6 down, and I'm going to subtract the powers. So 3/5 take away 3 is negative 12 over 5. I worked that over in this box. Now I'm going to handle... Oh, that's now ready for calculus if I put a 1 in there. So this is dy dx. Okay, this times this, that's definitely not year 2. But we can pretend there's a 1 there. That times that is negative 72. That times that is 5. Reduce that by 1, I think is negative 17 over 5. Do you know how I got that so fast? I took away 1. 1 is like 5 over 5, so I took another 5 away from negative 12. And I got negative 17. You do not have to do it that fast. You can do a little working box if you want. This times this is dead easy because it's a 1. 2 and 3/5. Reducing that by 1 is dead easy because it's in mixed fraction form. And there we go, that's dy dx. But no way is that tidy enough to put in a multiple choice box for later on use. So we've got to tidy that up. So here's me tidying it up. There's a negative power. I'm going to put it underneath the fraction line without the negative. The type of rooting it is going to go on a little root symbol. The type of powering it is going to go there. This I'm going to change to a mixed fraction. That's 13 over 5. And that, again, I'm going to use the... Oh, wait on, that's... What's that? That's 8 over 5. So the type of powering is 8. The type of rooting is 5. Now that looks awful, but it's the best we've got. So this goes in the top row. And this gets copied into the bottom row. And that's what you would use if you had to work out tangents and so on. You have to be very careful with your handwriting here to make sure that people understand the difference between what's big and down low like this 5 and what's little and up high like that 5. Now does anyone want to ask anything about that? Kim?
How do you, with the 6x side of the equation, how do the powers
Tell me where I am.
from E?
E, yeah.
The rest of it, how does that change? I don't understand.
How does that become that?
On the other side of the equation.
How does that become that?
Yeah, and
I just subtracted the powers. 3/5 take away 3 is negative 12 over 5. I worked that out here.
oh, okay.
Yeah?
Yeah.
It's just subtraction of powers when you see one x and you see physically another x.
And
Vicky? Oh, sorry.
How
Kim?
do you carry on to the end?
Well, this is now the step where you have to do that times that. So that's why I put a little 1 there. So I could do top times top, bottom times bottom. 5 times 1 is 5. Negative 12 times 6 is negative 72. Then I reduced this by 1. I did that very fast. Reducing by 1 is like taking away 5/5. So it was negative 12/5 and now it's suddenly negative 17/5.
Okay, thanks.
Okay, any other questions? Okay.